Angle. A reference angle is the measurement of an angle. Let's see, it's the angle measured off the x-axis. Bless you. The reference angle is always the measure of the angle of the distance it is off of the x-axis. First quadrant, in quadrant 1, it's whatever theta is. It's whatever the angle is. Okay? Because if it's 50 degrees, it was 50 degrees to come up from the 0 to wind up on your terminal side. Okay? If you want to be fancy with it, that instead of the position of the angle, how far off it is from the x-axis is where the terminal side is off the x-axis, but you kind of get the idea. If I go into the second quadrant, it's coming up from 180. It's how many degrees up from 180 it is. If I'm in the third quadrant, it's how many degrees past 180 or past pi you are. And then down here, it's how many degrees you are before or from 2 pi. So you're always bouncing, and this is the term I was saying the other day, how far are you bouncing up and down from the x-axis? You're always worried about bouncing from the x-axis. By doing that, what happens is that any angle that's placed in the first quadrant has 3 other reference angles within 1 revolution. What happens is this. If I take something really generic, 50 degrees. If I say that that is 50 degrees, if I move that angle into the second quadrant, that new angle would be 50 degrees over to here. How much would this angle be going to the second quadrant then to have the same reference angle? 130. Yeah. It'd be 130 degrees then, because you're up 50 degrees here. Does that make sense? Mm-hmm. The reason that we do this is because these two values, when they hit the circle, which we'll get into probably on Monday, when they touch the circle, they're going to have the same radius. And if they have the same radius and the same reference angle point, they wind up being horizontal from one another. Horizontal lines in the XY grid share the exact same Y value. Remember that? And then it spins itself down as you come down this direction. If I'm down 50 degrees, that means theta is 180 plus 50, so it'd be 230. Yeah, think about that. Makes sense, you add 50 here. Hello. And what happens if these two guys become vertical of one another? If points are vertical of one another, they share the same x coordinate. And then I hang a right and then go back horizontal. This one becomes down 50, so it comes all the way around at 310. And again, it shares all these values. That's the reason why we worry about that thing called a reference angle. Those reference angles are going to allow you to figure out ordered pairs for certain values, basically your special right triangles, within each of the 4 quadrants, just by moving it that reference point. So if you're able to calculate a reference point, how far something is off an axis, everything else falls into place, okay? Everything. So I know that when we drew that, we started to draw our first sketch of the unit circle 2 days ago, you guys were all going, it's quite honestly, if you can draw a 30, a 45, and a 60 degree angle, everything else mirrors itself around because of reference angles. Nothing else changes. It's 3 angles built into this giant web of craziness. All right? That's kind of where we're headed. But I wanted to make sure that, because I know that I've said that term reference angles a few times the past few days. I just wanted to make sure I gave you guys a full definition of it and what it does in the grand scheme of things. Not bad? All right. So then, what do we have left to talk about in 13.2? We have, we'll come back to this, we have this stuff. Arc lengths and area of sectors. Now, before we do this, I'm going to wait a couple of minutes. You guys did central angle over 360 times 2 pi r for the arc length. Well, before doing all that, what's 2 over 360? 1 over 180. So this is the exact same thing as pi over 180 times r. And our angles in this case, we don't call it an angle, we call it, well, we call it an angle if it's in degree, but isn't this degree to radians times your radius? Arc length is just radians times radius. It's radian value times radius. So if you have a 40 degree angle with a radius of 5, all you do is convert 40 degrees to radians. You multiply it by 5. And there's your arc length.
Why didn't we just learn it that way last year?
You did.
Why couldn't we just learn radian measure last year?
You did. You just didn't call it that.
Why can't we call it?
You just didn't call it
radian
that.
measure.
So we just have to do
Hello,
it
Mr.
again.
Reyes, how are you?
I heard
Hello,
you.
Mr. Murphy.
They all just got mad about why did we learn about radians last year? Because I just showed them that central angle over 360
Take a
times
seat.
pi r
Enjoy.
is just radian.
Welcome to Honors Algebra 2, everybody.
It's really interesting.
They don't throw stuff. Throw stuff at them.
I want force.
Throw stuff at them. You know, look at them all. They all just got scared and sat in the back. What are you afraid of?
No, this is what they do in my class. All of us in the back.
Why?
I have no idea. They just do.
You're sitting there shaking it. What do you think we're going to throw something? I at least got to know who you are before I throw something at you.
I got hit in the.
So
These people look familiar.
only one of you guys are brave enough. See, she likes you. She's a good. You'll like her. She's really nice.
Get to know these kids really well. They have all the answers next year. Yeah.
So I was scared Federico. You didn't have Federico. No. I thought I was cleaning out my old folders and like on the computer, and I found her older sister's quadratic formula video, and I thought that was her sitting next to her as a child. Not like she's a child anyway, but you know. And I was. It's the other one. The other younger one.
The other one I won't have.
Is she gonna come to high school too? So I had 4 of you. Are there more of you than 2?
There's.
Yes. Because I've had. You're my 3rd, right?
Yeah. 4th one's next year.
Is there any more than that? It's just 4, right? Okay.
They might win.
I think you might win. It's great. It's to see the families just coming. These just keep going. All right. Anyway, so you guys are doing arc length right now, right?
Just did, yes.
All right. So arc length,
What a
We never
coincidence.
did
Not
this
crazy.
last year.
central angle.
Why did we come in last year?
You know, I don't know
How
why
many
you
of you
guys.
remember this from last year?
Well, they're complaining why they didn't come up to visit last year.
Yeah.
Because
Wow,
you teach second hour and I don't have a second hour class.
There you go. There's your reason. You have
Wait,
12
but I
hours?
was in 12 hours.
Yeah.
You have 12 hours?
Yeah.
Bring them up. We'll do it again 12 hours.
Okay.
So when you guys are doing right now, yeah, we used to go to Judkins all the time. What you guys did in geometry is arc length. Arc length is the distance on the perimeter of the circle. So what you're doing is you're looking at the portion of the perimeter, the portion of the circumference. So what you guys are doing is you're taking your central angle, whatever that is, multiplied by 2 pi r, which is circumference, and you're dividing it by 360. Well, right now in honors, what we're talking about are things called radians. Radian measure is part of when you start at 0, 90, 180, 270,
This would have killed me if I didn't taught you this last year.
and 360.
You hated circles to begin with. Why would I hate this?
It would
So,
have helped us.
If you go all the way around a circle,
made things so much
the
easier.
distance around a circle is 2
I'm
pi.
97 now.
You multiply by the radius to get the circumference. You guys agree with me on that?
Yeah.
So what we do is we convert everything from degree measure into radians. So instead of being 360 all the way around, it's 2 pi. What's half of 360? 180. So what's half of 2 pi? Pi.
Your kids already know this. You don't
I
need
know. What's half of 180? So what's half of pi? Now if you count by fractions, which I know is hard for some people, you'll be able to do this. 0, 1 half, 2 halves, 3 halves, 4 halves, and that's where all these fractions come through. So what we do here is when you start putting things in terms of pi's all around a circle, you're actually putting them into what are called radian mode. So my guys, in the past couple of days, we started taking values, we just did this example of 40 degrees, and we wanted to convert that to radians. Well, to convert that to radians, all you do is you slap a pi next to it and divide it by 180. Sir?
Is this going to be on the final?
Yes.
Oh no.
So if you look at this, what's 2 over 360 simplified to be? 1 over 180. It's the exact same formula to convert from a degree measure to a radian measure
As it is to do arc length.
as it is to do arc length. The only difference is you then multiply it by its radius. That's all it is. So in where was it? One of these. So if I have the arc length, we'll talk about area of a second in a second here. If I want to find the arc length of a circle that has the radius of 9 and a central angle of 60. Well,
You guys can do that. You just did that, right?
take your angle over 180, slap a pi next to it, and multiply it by r.
Which for us is the angle over 360 times 2 pi.
And all we're doing is simplifying it ahead of schedule because you don't, I mean, you can write down 2 pi arc length. It's too many numbers. So, fractions.
Yeah, you're gonna do it my way.
I'm so used to doing it. I am so used to doing it that way because in geometry I always do it that way because, you know, math. So, fractions. Hey, tell these guys what they don't get to use for trig. Calculators.
I told you you had to memorize like 18 values, you remember that? This is one of them. I said 18 values, sine, cosine, tangent, cosecant, cosine.
And there's your arc length. And then we'll be able to graph them too. Hey, how good are you guys at special right triangles?
But all of that other.
That's a good question. You might want to make sure you're really good at special right triangles. Because everything you need to know is in a special right triangle. My guys kind of know that, but they're not quite there yet. Okay.
It's because they decided
I
not to
don't like you, but that's okay.
Hey, you're gonna do all this all over again.
I know.
I believe you.
That's true.
I
So-
don't remember 45.
What we do with our trig unit in algebra 2,
Those are the only thing I remember.
yeah, what we do in the trig unit here is, I counted it out, it's about almost 8 weeks long of just trig, where we go through the first couple of weeks, you get to use the calculator, and then the calculator goes away for the next 5 to 6 weeks, where you won't do anything with the calculator. You don't need one. Not at all. Everything gets placed within a circle, and you're able to draw out and just simplify a fraction.
So,
All
you
it is.
believe me that you'll be doing this all over again a whole bunch of times?
It's not bad. Tell them it's not bad.
It's horrible.
Shut up, Shut up, Radke. Nobody likes you.
Alright, back downstairs, we got work to do.
Goodbye, everybody.
Bye, everybody!
Tip your waitresses. They're all frightened now. Did you scare them?
I think you scared them.
I did.
Yeah.
We didn't know what to say.
Yeah. Oh, hey.
Sending this stuff to Emma, I'm confused.
I don't know why I was so frightened for them.
I wouldn't believe
I don't know why.
What's that?
Why didn't we do this
I'm
last year?
so
We were in
mad.
12th hour.
We were in 12th hour. Did you have a 12th hour Algebra 2 class last year?
Yeah.
Why didn't you take us up there?
No, it just so happened we talked today and say, hey, you're doing arc length? Yeah, so am I. Hey, come on up.
So,
Why couldn't we have gone down?
because if we would have learned this stuff last year, right now I wouldn't be confused.
Why did he grow?
I think
It would have made everything so much
Monday.
easier.
Monday.
Literally.
We did learn it last year.
No, not radian measure though. We would have been like radian measure. Like,
But radian-
simplified, just like that.
Remember though, radian measure for both of these things, so what they do for arc length here is, the Algebra 2 book writes it out differently. What I showed you guys here a second ago, we did angle over 180 times pi r, and that was how you set up for arc length.
I think this is bad. We look at the next week's though.
Good luck on that. So then, what they do here in the Algebra 2 book is they say that the arc length is radius times theta. Theta is just degrees in radians. So theta, if you think about it, theta is this chunk right here. That's theta. It's just converting it into radians. Okay. So theta is angle over 180 times pi. It's just radian measure. Okay. It's a really fast thing to do. Same thing as area. If you remember, area of a sector was, you'd figure out the central angle over 360 times the area of the circle. Well, what we do here is, instead of writing it all out long form, they take the area of the sector. Remember, the sector is the piece of pie, the piece of pizza. Oh, speaking of pie, you know next week is Pi Day? So,
Wait, which day?
on the 14th?
Oh, yeah. Wait, isn't that Monday?
Tuesday, I believe.
I'm so
If you look in the Jewel ad for next week, you can buy an 8-inch apple pie for $3.14, and they cut out a pie symbol in it, in the crust.
You should get some.
I'm so buying a pie on Tuesday. Yes, sir.
Wasn't it like in 2015 when it was like actually like extra high day? It was like 314.15.
There was, but it's 3.1415, and then that 9 something other, yeah.
So when you use 1,500.
Maybe on Pi Day I'll show you guys a video. I've got a really cool video about pi.
Yeah, it shows them.
Can you bring in some pies?
I just told you on Tuesday, I think Monday and Tuesday, Jewel, it's a grocery store. They sell food. They're selling 8-inch apple pies for $3.14.
Why don't you
Like,
Because
can you
it's
bring it
pie.
in?
You can, go ahead.
Bring us an apple pie, Maddie.
Yeah, man.
So the area of the sector then
I don't have money.
is 1/2 the radius squared, oops, times theta. And again, theta is just your central angle. Okay. And the reason that the 1/2 comes into play is, if you think about if I place theta as radians, it's 1/2 your radius squared times your central angle over 180 times pi. And then if you put that back together, that's just your central angle times, why do I keep squaring my central angle?
Square. So make it around.
It's the exact same thing as the formula you did last year in terms of finding the area of the sector. Take the angle over 360 times pi r squared. It's the same formula, but yet you're just converting it into radians. So just keep things in simplified radical form, and we'll be happy. Sound good? Finish the worksheet.
He really wants to get to finish.